Hello and welcome to C++ Weekly. I am your host, Jason Turner. I am available for code reviews and on-site training, as I'm sure you are aware at this point as a regular watcher of C++ Weekly. And if you're not a regular watcher, you should go ahead and take this moment right now to subscribe to the channel. In this episode, I want to address a concern from a few episodes ago. Not that long ago, I made a comment about avoiding pointer arithmetic, and a lot of you really seem to take issue with the fact that I didn't explain why you should avoid pointer arithmetic. So I will attempt to go into that right now. This episode is sponsored by JetBrains. To keep up with the pace of progress in the C++ ecosystem, we need tools that help us work quickly and effectively every day. CLion is a cross-platform C and C++ IDE by JetBrains that makes this challenge its main goal, integrating code analysis, refactoring, and the best ecosystem tools natively into your day-to-day development workflows. JetBrains has just recently launched CLion Nova, a version of CLion with the C++ language engine from ReSharper C++ and JetBrains Writer. It addresses long-standing performance and quality issues and unifies the user experience across all our C++ tools. Learn more and use it for free. Check out the link in the description. Okay, so at its simplest, pointer arithmetic is literally taking a pointer and adding a value to it. I'm just going to forward declare some sort of structure. And this is all fine and well. I can have a pointer to something and only have it forward declared. The code's going to compile just fine. But I can't do anything with this pointer yet. Like if I wanted to dereference this pointer and return a value to it, then I'm going to get this return type struct s is incomplete. Or if I wanted to do this, where I'm adding 1 to the pointer. And now if you don't know anything at all about pointer arithmetic, you might be saying, why in the world would Jason be adding 1 to this pointer? I'll explain that in just a moment. Now, for those of you who are less familiar with some of the tricks that I do here in Compiler Explorer, I do intentionally forward declare without implementing functions fairly often so that the code doesn't get simply removed by the compiler. So let's go ahead and look at the Compiler Explorer output here, which the build is failing, and that's because I can't add 1 to something with an incomplete size. It's very straightforward, actually. So let's add a couple of integers to this thing so that we know what its size is. And now this code compiles. I am adding 1 to this pointer, but it does nothing, and I'm not calling useRef. So let's go ahead and actually look at pointer arithmetic. So by adding 1 to this, you may or may not be surprised to see that I get 8 added to this input value, and then I am passing that here. And that's because if you add 1 to a pointer, you're not actually literally adding 1 to it. What you're saying is, go to the next object of this size at this memory location. Now I'm getting this error that I couldn't execute the program because I haven't implemented useRef, but that again was intentional. So I'm going to create an array of these things. I'm going to create an array of 2 of them. I'm going to default initialize them, and then I am going to pass usePointer data. Now this thing, this is all C code basically up to this point, is going to have no problem taking a reference to an array, which is what data is, and making that a pointer. Arrays in C very much like to decay to pointers. It's definitely one of the main sources of bugs and memory errors in C++. So I'm passing this thing to usePointer, and we can see in main, I get a pointer to this thing. I call useRef, so it's inline to the call to useRef after adding 8 to the pointer. Now, this is perfectly fine. So this is safe because, quote, we know it is. Now, as soon as I do this, where I pass in the what would be the third element of the array to the function useRef, I'm now an undefined behavior. I've just created a reference to an invalid object. This is unsafe. And this is where the dangers in pointer arithmetic come in. And you're watching this and saying, but Jason, I've never done anything like that before. And I'm going to tell you that you're probably wrong and you have. This is an incredibly common pattern to see in code that does string parsing. You just iterate through the input string until you get the null terminator, right? That's perfectly normal thing to do. But if someone passed you a string that was not null terminated, this code has a memory error. And then you tell me, oh, but Jason, of course I've never done that before. So I say, well, perhaps you've done something like this. This comes down to exactly the kind of bug that I had in ChiScript in many places. And this is why I tell you, you need fuzz testing if you're doing anything at all like this. So this is meant to just show you the bare fundamentals of why pointer arithmetic can be dangerous. And therefore, you should write code that avoids pointer arithmetic. And we have tools for that in modern C++. And they're not complicated tools. If you're using C++ 11, you can create something like span. If you're using C++ 98, you can create something like string view. They're not complicated. So by using something like string view, we can end up writing code that can be hopefully, at the very least, safer. We have things like empty, and we know that we don't have any characters left in our string view if it's empty. We have starts with, and we can say, if the input starts with the open brace, then we know that we need to parse the block. We can do a substring. So if we get here, we know the string is empty. We exhausted the input string, didn't find the open brace that we were looking for, so we return. But if we get past that line, we know we did find that open brace, and it's safe for us to ask for the substring of the remainder, which might be an empty string, but that's fine because this code, again, is going to loop over all the characters, and if it doesn't have any characters, it's not going to do any looping. So if you are careful with code like this, the worst that you can do is accidentally create an infinite loop, perhaps with something like that, which you just keep calling starts with on an empty string. That's always going to return false. We can consume input strings. We can avoid directly doing this pointer arithmetic, and it eliminates a class of bugs. It's not foolproof by any means, but this is why I said you should avoid pointer arithmetic. Because if you are manually keeping track of how many objects are in an array, or you are looking for some sort of sentinel value, like a null terminator, you will, at some point, get yourself in trouble with undefined behavior. And I can say that from experience. So use things like string view, span, I've covered those in other episodes, and always test your code with as much testing as you possibly can, as I have said many times, including fuzz testing. So thank you for watching this episode of C++ Weekly. As I said before, please be sure to subscribe and give this video a thumbs up.